Alright, so when I think of science misconception, I kind of think of the way I viewed science when I was in elementary school. I would hear science and I would think like, ew, that's boring, I don't want to do that. And I think that's because I would associate it with the boring stuff. So I remember reading out of science newspapers. We would have to read through the entire newspaper, study it, take a test over it. Or we would have to read out of the big science textbooks and learn the vocabulary words and all that. So that's kind of why I associate science with boring, or why I did, I guess. But then when I think of misconception along with that, I think of like your thought process until it's like proven otherwise. So like you think something is the way it is, even though that's not right, and whether that's you or the teacher that proves it otherwise, you just have those misconceptions. And then thinking about common science misconceptions, I talked with my younger siblings actually about this because I was curious what they thought as well. But two of the big ones we came up with was like refraction. So if you were to like stick a pencil in a glass and it's like wavy or it looks broken in half, a kid would think that it's actually like wavy or broken in half until you explain and kind of prove that misconception wrong, or they figure it out themselves. And then we also thought of like when you have water in a glass and you transition it into a bigger glass or a smaller glass, they think that the amount of liquid changes. So those are two of the misconceptions we came up with. So I definitely want to leverage these misconceptions in a way that helps students kind of discover it on their own. I want them to have like those wow or like aha moments where they feel like they've figured something out. I want them to feel like they did it themselves. I feel like the teacher's role is definitely to guide them and know those questions to ask to help them get to that point, and design those experiments to help them get to that point where they feel like they did it on their own. I think it's really cool to have those moments where you feel like, wow, I discovered this on my own, or I figured this out on my own. And I want them to feel like that pride when they kind of discover something they thought was one way and then it actually is another way. So the progression of standards is having students kind of master and learn a key concept in K through 2, maybe like a more broad concept that they will continually build off of as they go through higher grades, and then they will kind of refer back to their prior knowledge that they've learned on those previous subjects or previous ideas, and just continually build off of that and use their prior knowledge to reach those higher levels. And then one disciplinary core idea I chose was a weather and climate. So it starts out in K through 2, students initially learning kind of the combination of weather patterns, what they're made up of, how they're made up of wind, snow, rain, temperature, etc. And then kind of vaguely how they record weather patterns over time. And then they will go on in 3 through 5 to learn more specifically those weather patterns, how historical weather patterns can be analyzed, climates, and then in middle school, they would go on to learn how all of that is really interconnected and how those complex interactions determine the local weather patterns, and then also how weathering, erosion, changing landscapes play into all of that. So it just kind of shows the progression as they get older. So the 6th grade physical science standard addresses matter and its interactions, and it specifically says make observations and measurements to identify materials based on their properties. So this overlaps with the physical science 1 structure of matter. And so basically that says that coming into the standard, students should have previously learned in K through 2 that matter exists as different substances that have observable different properties, and the objects can be built up from smaller parts. And then in 3 through 5, they should have learned or should be currently learning that matter exists as particles that are too small to see, so matter is always conserved. And then measurements of a variety of observable properties can be used to identify particular materials. And then branching off of that in 6 through 8, the fact that matter is composed of atoms and molecules can be used to explain the properties of substances, diversity of materials, states of matter, phase changes, and conservation of matter. Alright, so I first want to start off with, I really enjoyed learning about the 5E learning process. Going into this, I had no idea how to even go about teaching science in the classroom, but this has helped me feel a lot more prepared and a lot more excited to do it, because I think it's a really great way to bring a lot of things together, and it's easy to put a lesson together like this. It makes it a less daunting task. So going through all the stages, starting with engage, the biggest thing is obviously to kind of get the students interested, get them asking questions, get them thinking about the learning that's about to occur. I also think it's a good time to kind of for the teacher to see any misconceptions that the student may have, and then any questions and what the best way to address all those is going forward. And with this, I think the best way to go about it is with a quick little video, with a quick little experiment to get students really thinking like, wow, how are we going to do this? I'm excited for this. And then the explore phase is time for students to discover on their own or with each other, and it's basically just time for them to form their own assumptions about the learning that's occurring. And obviously we want it to be built in with failure so students can learn from that failure, learn how to build up from that. And then we want them to kind of just be puzzled from this and want to continue learning more and have their questions answered. And then this should definitely be a hands-on activity, doing a simulation of some sort, something the student can do in many different ways, and there's many opportunities for that experiment to go. And then the explain stage, students have the chance to kind of like defend and express their thoughts on what just happened. They can kind of collaborate with each other, get a general consensus of thoughts. And then this is also a time for the teacher to kind of jump in and explain concepts further, elaborate on those questions, misconceptions. So definitely a time for everyone to just kind of come together, see what learning has occurred and what learning still needs to occur. And then I think a great way to do this is a lot of discussion through like mind maps on paper, making foldables, love doing that, and then just like fun learning games with like vocab. So definitely still trying to make it hands-on while they're still learning about the concept. And then elaborate is the time for students to apply those new concepts, figure out those questions, and definitely take in consideration just like the data they've accumulated, evidence they've accumulated, and really put that to the test again. They should be still exploring and learning, maybe through like real world activities, through more experiments. And I think this one should be definitely hands-on, where they have the chance to apply again and just explain their thought process behind everything. And then the final evaluate stage should definitely just sum up the learning experience, what students took away from it, if they still have any questions about it, and them really assessing their own learning, while also the teacher is still assessing them throughout the whole process. I think journaling is a really cool way to do this. It's something students can look back on and something teachers can reference to see what students have learned. So I think of the engineering design process as definitely pretty similar to 5E, just more flexible. It still goes through the stages, but the stages are ask, imagine, plan, create, and improve. So again, similar to 5E, but I think it's more flexible. This is something I remember learning when talking about it in class, was the flexibility of it, and students can kind of jump in at any point. It doesn't have to follow the specific order like the 5E does. So that was one of my favorite things about this process, and it's so good for all learners. And I think that deep learning occurs throughout the whole process, but I think the biggest step is the create step, because that's when students kind of get to put it to the test, apply their own knowledge, apply what they've been studying, kind of put it all together while still having questions, and they get to see it play out. So I think that is my favorite stage in the process. Alright, to sum it all up, I really enjoyed the semester being in class. I'm very, very sad we didn't get to finish in person and get to be with our peers and all the professors, and actually get to, teach the lessons, so that was really hard. But I do appreciate all the learning we did get to do together. Some of my favorite things we did, definitely the Legos right before we left. That was such a fun thing to do, such a fun thing to kind of learn about and how we could do that with our students. And then definitely learning about the 5E learning, which I mentioned earlier, that just has helped me feel so more prepared, so more comfortable with science. So I really loved learning about that process. And then especially also learning about the science standards and how to kind of work with those makes me feel so much more comfortable with that too. Also, I won the Kahoot for the science standards, so that will always hold a special place in my heart. It feels really good to see your name on top of the Kahoot podium. So that will also be one of my favorite memories of science class. I don't think I have a least favorite thing we did, not off the top of my head. Even when we moved to online, it felt like everything we did was very beneficial. There was nothing that I really dreaded doing, so yeah, I enjoyed it a lot. Again, very sad we didn't get to finish together, but I enjoyed this class a ton, and I will definitely take a lot of this with me going forward. So thank you for a great semester.